Example 3, we're going to differentiate this again. Again, we need to keep in mind that there is a product rule here. So we're going to make sure we apply product rule. So when I differentiate this, I'm going to differentiate the x. So I get 2x times cosine of y squared plus x squared. The derivative of cos is negative sine. And then as a chain, I have to differentiate the inside. In this case, the inside is still a squared function. So it's y squared becomes 2y. And at this point, I'm going to tag on my derivative of the inside function y prime, or dy by dx. Okay, so there's my product rule for the left-hand side. And then on the right-hand side, this is just going to become the derivative of y, which is dy by dx. Okay, so then at this point, I'm going to group my terms. So dy by dx, I'm going to factor that out. And out of that factor term, I'm going to have negative 2 x squared y, and then sine y squared. The dy by dx on the right-hand side becomes minus, so I still have the minus 1 on this side. Okay, so that represents the dy by dx terms. The other term that I have to account for is this one here. Now that's going to end up on the right-hand side of the equation now as negative 2x cosine of y squared. Okay, so I can probably get rid of the negatives. So when I divide, I'm going to make sure I'm going to get rid of the negatives when I divide. So dy by dx, that's going to be equal to, these negatives all become positive, positive, positive. So my derivative works out to be 2x cosine y squared in the numerator, and in the denominator is going to be 2x squared y sine of y squared minus, oh sorry, that's going to be plus 1. Okay, so that represents the denominator of that derivative. In example 4, we are trying to find the second derivative given the first derivative. Now, the second derivative, well, it's just differentiating this expression. So I'm going to find d squared y over dx squared by differentiating this expression. And when I do this, I'm going to differentiate the y. It's a product, so maybe I should just make sure that I have the product rule here. So there's a product, so I'm going to differentiate y, and I'm going to make that y prime times cosine of x squared plus y times, the derivative of cosine is going to be negative sine x squared, and then there's a squared embedded inside, so I end up with chain rule times cos x. Okay, so I'm just going to change the color of this one here. I'm going to change that to maybe green. Okay, and I want to make note that that dy by dx that I had originally is the same as y prime. So when I want to get rid of that y prime, I can do that by replacing it with the original derivative y times cosine of x squared. So that will give me the expression for the second derivative, d squared y over dx squared. And I can then express the right-hand side of this expression with just x's and y's. So replacing that y prime, I'm going to replace that with y times cosine of x squared. And then I can put the rest of that in. This is going to be cosine of x squared. So I end up with cos squared in this case. I'm going to get my signs here. So negative. My coefficient is going to be 2xy. And then I end up with sine of x squared. So there's my second derivative. I'm going to clean this up a little bit. I'm going to group some of these things together. So we could factor the y out. In this case, I'm not going to bother factoring the y. I'm just going to write it like this. Y times cosine squared of x squared minus 2xy sine x squared. And there's my second derivative. So d squared y over dx squared is going to be this expression with just x's and y's.